y'all, so for this challenge, it's gonna be the diffusion challenge. We know that diffusion is when molecules move from an area of high concentration to an area of lower concentration. So I took some supplies from my kitchen and I had a couple beakers, but you don't need any fancy science supplies in order to do this challenge at home. You can get as creative as you want, use whatever supplies you have. I'm gonna show you what I did and I can't wait to see what you come up with, all right? All right, so what do we mean when we say high concentration and low concentration? High concentration, basically everything's packed in together. Low concentration, it's kind of spread out. So we're gonna look at my examples to make sure we're on the same page. So here I have substance A and substance B separated by a barrier. Which one has the high concentration? Yeah, A does. So A has a high concentration and B has the low concentration. So where will the molecules move? Where will they diffuse? They're gonna diffuse from A to B. They're gonna spread out from an area of high concentration into an area of low concentration. How about with C and D? Where is there a high concentration? D. So molecules are gonna move from D to C, from an area of high concentration to an area of low concentration. All right, how about with E and F? Where is there a high concentration? There isn't really one. E and F look about the same. So where are molecules gonna move? They're not just gonna stand still. So molecules are gonna move both from E to F and from F to E. All right. So we can use those principles now to help us understand some diffusion we might see in our everyday lives. I'm going to show you two examples, and here are the materials I have. I have a bowl of regular water from my sink. I have some Skittles. I have some food coloring. I have two beakers with 250 milliliters of water in them. This beaker has cold water and this beaker has hot water. So the first thing I'm going to do, 3 Skittles. I want 3 different colors. Oh, there's like a lot of red ones. I'm gonna spread them out in my bowl of water. All right, so I'm gonna put the Skittles in my bowl of water. Make a prediction, what do you think is gonna happen? All right, I want you to explain why this happened. Now we're gonna do our second demo. So for this one, take the blue food coloring, all right? And we're gonna watch the molecules diffuse into the water. So make a prediction. What's gonna happen when I drop the food coloring into the water? Okay, that looks pretty cool. I'm gonna actually empty this out and then we can see what happens when I drop the food coloring into the cold water and the warm water at the same time. So I have 2 beakers now. They both have 250 milliliters of water, but this beaker, I stirred some ice in, and this beaker I microwaved for 1 minute. All right, I'm gonna take my drops and I'm going to put green food coloring into both, hopefully at the same time. So based on what we've seen here, if you were going to say make sweet tea, so you make tea and you wanted to add some sugar to it, would it be easier to add it to the cold sweet tea or to the hot sweet tea? All right, I want you to explain your reason. You can answer in the comments or you can send me a message. All right, now for the challenge. You're gonna show me an example of diffusion. Can you show me an example of diffusion with food, with drinks, with something that you smell, anything? If you don't have these supplies, I want you to show me something that you came up with that's even more creative. All right, I can't wait to see what you come up with. I love you guys, I miss you guys. I hope you're having a really good day, and let me know if you have any questions. Bye.